Okay, we're still looking at systems here, but now we're going to now it's going to be inequalities. Probably one of the easier ways to solve this is to look at graphing. You probably graphed inequalities in Algebra 1. You may or may not have done a system. And if you did, it was probably 2. We'll have a couple systems with more than 2 equations on here. So looking at this graph, we got a dashed line and a solid line. If it is a solid line, what does that mean? Do what, Gavin? Okay, so if it's a solid line, that means that it has an equal to on the inequality. Okay, it's equal to all of those values that is on that line. So if it's dashed, that just means that it is not equal to. Number 2 says that points x, y lie in the feasible region. The feasible region, that's just the area that satisfies both inequalities. Okay, it's clearly up there in the shaded area. So any point that would be in that area would be considered a solution. Any point outside that area would not be a solution. Okay? So, Alvin, what is one point that would be a solution on this graph?
Negative 2, 0.
Okay, negative 2, 0. Daniel, what would be another one? Negative 3, 0. And Greta, what would another one be? Negative 3. Say positive 2 or negative 2?
Positive 2. Or negative 2.
Negative 2. So negative 3, negative 2. Dalton, what is one that would not be?
That would not be a solution?
Yes. 0, 0. Jake, what's another one?
1, negative 1.
1, negative 1 would also not be 1. Alright, the point 0, negative 3, which I'll put in red up here. Would that be considered a solution to this system?
Yes.
Yes or no?
Yeah.
Is it on a dashed or a solid line? Dashed line. So is it equal to that? No. So it would not be a solution because it's on a dashed line. So now actually going to the problems where we'll be graphing and shading. So I would get these. Most people are comfortable with slope-intercept form. That's probably the one that I would go with. So Helene, on that first equation, what is my y-intercept?
It's 2.
And my slope would be what?
1.
Okay, so you can go up 1 over 1. Normally if my slope was just 1, I'm going to go up 2, right 2. It just saves a little bit of time. I don't have to write in as many points on there. And it's going to give me the exact same line. And David, does this need to be a solid or a dashed line?
Solid. It's equal to the...
Solid, yep, solid because it's equal to. On the second equation on there, Meredith, what's my y-intercept?
1.
And my slope?
Negative 2.
Okay, so I'm going to go down 2, right 1. And Jacob, is this line going to be dashed or solid?
Dash.
Why?
Because it's not equal to.
'Cause it does not have an equal to. So now let's talk about the shading. I've got, going back to the first equation, I've got y is greater than x plus 2. So common sense, would that tell me to shade above or below that line? Above. And then I've got y is less than, so am I going to shade above or below that line? Below. So the area that ends up being shaded by both is that area to the left of that right there. All of that is what would be considered the feasible region. Do not get that confused with the area that is shaded by just one of the inequalities. Those would not be included in that. Going to 2 and 3. So on 2, Daniel, if I wanted to change this to y-intercept, what would I need to do? Or sorry, slope-intercept.
Subtract the x.
Okay. So I end up with y is less than negative x plus 4. Jeremiah, what is my y-intercept? 4. And what is my slope? Negative 1. So again, I'm going to go down 2, right 2. And up 2, left 2. And now, Alessandra, is that going to be a solid or a dashed line? For the top one. Dashed. Right. Going to the bottom one. Kiana, what is my y-intercept? And what is my slope? So y-intercept, I'm going to go up to right 1. Down to left 1. Because it's got the equal to, it's going to be a solid line. David, on the first equation, am I going to shade above or below that line?
Below.
Why?
Because,
What's the inequality?
because that's less than.
Because it's less than. Greta, on the second one, am I going to shade above or below? If it's greater than, am I going to shade above that or below it? Above. So the area, very similar looking to the first one, to the left of that. We can get you started on 3 because it does have one that's a little weird. X equals 3. That line, is that going to be a vertical or a horizontal line? Vertical or horizontal? Dalton?
Would it be horizontal?
Vertical. Okay, this throws a lot of people off. So the line x equals 3, a lot of people think because the x-axis is horizontal, that an x equals number would be, or an equation, would also be horizontal. But the way I want you to think about it is, if x is the only equation, or sorry, if x is the only variable that's in the equation, the x-axis is the only variable that it is going to cross. right there at x equals 3. All right. We need to change our thinking a little bit on the shading here, because you can't really shade above or below a vertical line. This is the case where you would need to think right or left. If it's x is greater than 3, am I going to shade to the right or to the left? To the right, because that's where the numbers are greater than 3. Would be on the right. So there's the area where the feasible region would be on that one. Hopefully you got that little corner down there on the bottom right. Once you're done with that, go ahead and turn it over, or turn to the next page. At the very top of your notes, or very top of this page, I want you to write shaded opposite. So we're going to shade these a little bit differently than we did the front, and I'm going to show you why. All right, and I would say the benefit of shading opposite the sign, so if it's greater than, we're actually going to shade below. If it's less than, we're going to shade above. The benefit of this is whenever you have a system with more than 2 equations. All right, so we're going to go ahead and graph it. I'm going to explain why you might not shade with the sign, and then we're actually going to shade opposite the sign, and maybe you'll see the benefit of it. So looking at this first one, I've got y equals 4. Is that a horizontal or a vertical line? Horizontal. And is this one going to be solid or dashed? Dashed. The line y equals x, what does that look like? Nope. Don't get this confused. This is the most basic graph in all of algebra. Do what, Daniel? It's just the parent linear line. So bottom left, top right. All right, if I was to write that, if I was to fill that in with slope and intercept, it would look like that. Okay. And then x equals 0, vertical or horizontal? Vertical, and it's going to lie right on top of the y-axis. Now, if you have 3 equations, a lot of times it's probably pretty easy to figure out. You could probably figure out where the feasible region is probably going to be without even shading. And I don't know where all my lines went. Give me just a second. There. So I want you to put your pencils down because I do not want you to shade this right now. I'm going to shade it up here, but I got a magical little button that I can just erase what I did. So if I was to go through this and I was to shade with the sign, so what we were doing on the front, my first equation, I've got y is less than 4. So would I shade above or below this? Below. So I'd take my pencil, try to give you as much of a pencil colored thing right here. Do not shade this, Daniel.
Oh no, I'm drawing the red line.
Yeah. So now I've got y is greater than or equal to x. So am I going to shade above or below that line? If it's greater, I'm going to shade above. So I'm going to shade that right there. And then I've got x is greater than or equal to 0. So that was this one. So am I going to shade to the right or to the left? To the right, where the numbers are greater than. So I'm going to shade to the right. Okay? And there's my feasible region. So you can probably tell why shading with the signs, especially when you got more than two equations, might be a little confusing. Okay? So the mindset, you got to kind of change your mindset a little bit if you're going to do it opposite the sign. So if I've got y is less than or equal to 4, I know my solution set is somewhere down here. So I don't care about this. So I'm going to shade opposite. So if it's less than, I'm going to shade above. I know my solutions, it's not going to be up there. So you can kind of think of it as you're taking a chunk of the graph off with each inequality. If I've got y is greater than or equal to x, and I'm shading opposite, would I shade above or below this line? Below. And x is greater than or equal to 0. If I'm shading opposite, do I shade to the right or to the left? To the left. And then now your feasible region is the unshaded area. And I think it makes it a little bit cleaner. You just have to change your thought process there as you're going through it. So looking at that, David, what is a possible solution for this graph?
1, 2.
Okay, 1, 2. Gavin, what's another one?
1, 3.
1, 3. Down here, it also asks for the vertices. Vertices is a fancy word for what? A vertex is a what? It's a what? Kind of just a corner. So a corner of the feasible region here. Alright? So, Alvin, what's one of those on here?
0, 4.
0, 4. Rachel, what's another one? So vertices is just going to be these corner points. So what's that one out there? 0, 0. And Jacob, what is this one out here? 4, 4. Going to go through this last one kind of quick, just because of time here. So I'm going to shade these opposite. So I've got x is greater than or equal to 2. If I'm going to shade opposite, is that to the left or to the right? To the left. Next I have y equals negative x plus 9. So there's my y-intercept at 9. Slope of negative 1. And if it's less than, am I going to shade above or below? Above. Y equals 1. Is that a vertical or horizontal line? Horizontal. If it's greater than, am I going to shade above or below? Below. And then my last line, I've got a y-intercept of 4. Again, I have a slope of -1. And the only area that this is going to shade that wasn't previously shaded is just this little half square right here. Did that in purple just to point it out. That's the only part that this is now, that line is going to take off the feasible region. So I can go through there. Any point in here could be a solution. So let's do 3, 5, and let's do 6, 2. Both of those could be considered a solution. My vertices that I know Gavin is going to write down, even though he's putting his stuff away, is going to be, I've got 2, 7. I've got 2, 2. I've got 3, 1. And I also have 8, 1. So as far as the shading, I don't care which way you do it, whether you do it opposite or you do it with the sign. I do feel if there's at least 3 equations though, so a lot of times these graphs end up being a little bit cleaner if you shade opposite the sign.